Example 2, I want to use a linear model to make estimates and predictions. So example 2.1, I want to use the linear model to estimate the balloon's altitude when air has been released for 5 minutes. So to estimate the altitude of the balloon when air has been released for 5 minutes, we locate the point on the linear model where the t-coordinate is 5. So I'm going to look down at the t-axis, which is down here, and find approximately where it's 5, which will be somewhere in this range down here. I'm going to then look straight up until I meet the line. So from this point, I'm going to go about straight line up until I reach the line. And then from there, I'm going to see what point corresponds to it on the vertical axis. So I'm going to go straight across more or less until I get to the vertical axis. And I'm going to see what point is there. So the a-coordinate of this point seems to be about 1200. So according to the model, the altitude is 1200 feet when the air has been released for 5 minutes. So we verify our work by checking that a result is consistent with the values listed in the table. Since the altitude is 1400 feet after 4 minutes and 1000 feet after 6 minutes, it makes sense that the altitude would be between 1000 and 1400 feet when the air has been released for 5 minutes, which checks with our result of 1200 feet. In example 2.2, I want to use the model to predict when the balloon's altitude is 2000 feet. So I'm going to look at the altitude axis, or the vertical axis, and find 2000. So here is 2000. I'm then going to go over until I reach my line. So I go straight over till I reach my line, and I'm going to drop this point straight down. So it seems that at a t-value of 1, or after 1 minute, the altitude is 2000 feet. Again, we verify our work by checking that our result is consistent with the value shown in the table. Since at 0 minutes the altitude is 2200 feet, and at 2 minutes the altitude is 1800 feet, it makes sense that at 1 minute the altitude would be 2000 feet. So in example 2, we found that when the value of the independent variable t is 5, the corresponding value of the dependent variable a is 1200. We say that the input 5 leads to the output of 1200. The arrows that I drew, or the lines that I drew in these examples, show the action of the input t equaling 5 leading to the output a equaling 1200. So an input is a permitted value of the independent variable that leads to at least one output, which is a permitted value of the dependent variable. For a value to be permitted, it must make physical sense and be defined. For instance, in example 2, the value -50 is not a permitted value of the variable a, because it does not make sense for the balloon's altitude to be -50 feet. Later in the course, we will discuss values that are not permitted for mathematical reasons. Sometimes we will go backward, from an output back to an input. For instance, in example 2, we found that the output of a equaling 2000 originates from the input t equaling 1. And the lines I drew in the example show the action of going backward from an output of a equaling 2000 to the input of t equaling 1.